Hello, this is Mrs. Lopez, and we are in module 3, lesson 3 for grade 7. We are learning how to write products as sums and sums as products. This lesson is more like an introductory lesson where we are making tape diagrams and finding areas of shapes using our equations. So here's the opening exercise that you will be doing in class, but as an example, I'll show you how to do it. So a sum of money was shared between Ross and Monica in a ratio of 3 to 4. If the sum of money was $56, how much did Ross get? Solve the problem using a tape diagram. So here we have Ross and Monica. Ross and Monica. And the ratio between them is 3 to 4, so Ross does 3 and Monica shares 4. 1, 2, 3, 4. They should be an equal size. Mine are not that equal. We know that the sum of the total sum of all the money is $56. And I need to see how much did Ross get. So I want to see this part right here. Or right here. That's what I want to find out. Okay, so if I look at this tape diagram, I see that in total I have $56, and also in total I have 7 boxes, all right? So if I take 7 boxes and divide 56 by 7 of those units, I will get 8 units. Oh, $8 in each unit, right? So if I have $8 in each unit and Ross gets 3 of them, I can multiply 8 by 3 and I will get $24. So Ross got $24. Okay? So that's just one of the versions of the tape diagrams that you can have. There are many other different versions that you might be able to use by yourself in class, and please use whatever works for you. Here we have example 1. So now we are diving into our lesson. Represent 3 plus 2 using a tape diagram. So here we have a tape diagram, and here I have 3 and 2. That's how I represent 3 plus 2. Represent x plus 2 using the tape diagram. That really is going to look exactly the same. The only thing is I don't know what x is. Is x smaller than 2 or is x bigger than 2? But it doesn't really matter right now. We just can write x plus 2. Draw a rectangular array for 3 groups of 3 plus 2. So here I have that group of 3 plus 2, the one that we did earlier. 3 plus 2, and I need a rectangular array to show 3 groups, so 3 groups of them. So I'm going to do it twice. So 3 plus 2 and another group of 3 plus 2. I can do it this way, or I can do it this way. So this is 3 and this is 2. I know it's 3 plus 2, and I repeat it. I take it 3 groups of them. So that's just a shortened version of how you can show the tape diagram for 3 groups of 3 plus 2. This is a more expanded version, and it's probably easier for you to understand at the very beginning. Later, when you don't have time or you're just too lazy to draw 3 boxes and label them all, you can just do it this way. This way is more efficient. Okay, so now we have three groups of x plus 2. More efficient way will be three groups of x plus 2. To understand it, I'm going to do it three ways. So x plus 2, and I will have two more groups of x plus 2 and x plus 2. When I do that, I want to go back to this example. I have three groups of 3, which is 9, and I have three groups of 2, which is 6. So together it's 15. This way, if I do it in rectangular array, I'll get 9. 3 times 3 is 9, and 3 times 2 is 6. So together it's still 15. It still works. If I have it, now let's go to our x's. How many x's do I have right now? I have 3x, and I have 6. So I get 3x plus 6. If I'm looking at this rectangular array, I will see 3 times x, or three groups of x, is 3x, and 3 times 2 is 6. So both of these, 3x plus 6, both of these work. This is more efficient because it requires you less writing. Okay, let's move on to the next one. This is where we get to the new term, distributive property, the one that you probably don't know about yet, but that's what we are going to learn today. The distributive property can be written as the identity A groups of B plus C. If I have A groups of B plus C, I have A groups of B and A groups of C combined together for all the numbers A, B, and C. Let's see how this formula works in our examples. Determine the area of each region using the distributive property. So here I have 11 times 16. 11 times 16 is going to be 176. And here I have 11 groups of 5, which is 55. So the way that I can write it is 11 groups of the sum 16 plus 5. And what I'm doing, I'm taking that 11 and I'm multiplying it by 16 and I'm multiplying it by 5, right? That's what happened here. So I can do equals 11 times 16 plus 11 times 5. And here, that's how I got 176 and 55. When I add 176 plus 55, I will have 231. That's how distributive property works. What you're really doing, you're multiplying 11 by both numbers inside the parentheses. Okay, let's look at this one, example 2. Draw a tape diagram to represent each expression. So here I have x plus y plus x plus y plus x plus y. So let's assume that x is a little larger than the y or smaller than the y. I have x plus y, and I'm adding another x plus y, and then I'm adding another group of x plus y. That's how I would show x plus y plus x plus y plus x plus y. If I'm looking at it this way, can I just rewrite it this way? I will have three groups of x, x plus x plus x, and I will have three groups of y. They're a little bigger, we assumed. Y plus y plus y. So here I have 1, 2, 3x plus 1, 2, 3y. And here I have the same thing. I have 3x plus 3y. How can I show 3x plus 3y using a tape diagram? I can do 3x plus 3y. Still going to be the same thing, isn't it? And if I take, or I can do it this way, 3x plus 3y. Initially, it looks exactly the same as this diagram right here. Okay, and here I have my last one, 3 groups of x plus y, and let's see if that makes sense as well. So I have x plus y, x and y, and I have 3 groups of them. I also have 3x plus 3y. Exact same thing. So which way is more efficient? Sorry, I can have another one. Here I have x plus y, and I have 3 groups. So I will have 3x here and 3y here. Still works. This way is more efficient because here you can totally see that distributive property. We have 3 groups of x plus y, and what we are doing, we are multiplying 3 by x and 3 by y, and we are adding them together. All right. Find an equivalent expression by modeling with a rectangular array and applying the distributive property to the expression 5 groups or 5 times 8x plus 3. So if I draw my most efficient way, I will get 5 groups of the sum 8x plus 3. That's what I have in parentheses, right? 8x plus 3 right here, and I have 5 groups of the whole thing. So instead of doing it 5 times, I can just write 5 and I can combine them all and multiply. 5 groups of 8x will give us 40x, and 5 groups of 3 will give us 15. So what I will have is 40x plus 15. I cannot do anything else because these terms are not like terms, so I can't combine them anymore. That's the lowest I can go. All right, so how do I show it using distributive property? I have 5 times the sum of 8x plus 3. And what I'm really doing is I'm multiplying 5 by 8x, which is 40x. And then I put my plus sign. And I have 5 times 3, which is 15. Probably should show that middle step when I have 5 times 8x plus 5 times 3. Okay. All right, so apply distributive property to expand each expression. Substitute the given numerical values to demonstrate equivalency. Okay, so first we are going to apply distributive property. So here I have 2 groups of x plus 1. What that really is 2 times x plus 2 times 1. And that is 2x plus 2. Okay, if my x was equal 5, I would do 2 times 5 plus 2 times 1 by looking at that number, imagining that x is 5, right? And so I will have 10 plus 2, and that is 12. Let's see if that will work in our simplified expression. So I have 2 times 5 plus 2, and that equals 12. 12 equals 12. It means I got everything right here, or correct. Okay, so now we have second one. we have 10 times the sum of 2y plus 5, where y equals 1. So let's see what it is when I just substitute y for 1. And I will have 10 times 2 times 1 plus 10 times 5. 2 times 1 is 2, that's what I had here. 10 times 2 is going to be 20. 20 plus 50, and that is 70. Let's see if I can get 70 when I simplify my expression first. So 10 times 2y plus 10 times 5, because that's what I'm doing. I'm multiplying 10 by both numbers inside the parentheses. I will have 20y plus 50. That's my standard form of this expression. And now I'm substituting 1 for y. 20 times 1 plus 50. 20 times 1 is 20 plus 50 is still 70. 70 equals 70. I got it all right. Okay, next one. 3 groups of 4z minus 1. I see subtraction here. I need to change my subtraction into addition of its inverse first before I do anything else. So I have now x equals 2. Or probably it should be z equals 2. Z equals 2. So on the side, I'm going to just substitute 2 for z right now. 3 groups of 4 times 2 plus negative 1. Okay, or I have 3 groups of 8 plus negative 1. Using distributive property, I can do 3 groups of 8 plus 3 groups of negative 1. Here I will have 24 plus negative 3, and that is 21. Over here, if I simplify, I will get 12z multiplying 3 times 4 times z plus 3 times negative 1. 12z plus negative 3. 12, now I'm substituting 2 for z. 12 times 2 plus negative 3. That is 24 plus negative 3, and that is 21. 21 equals 21. I got it all right. Okay, last one here. I have 9 times the difference between negative 3x and 11. Since it's difference, it's subtraction, I need to make sure I change it into its inverse first. So add the opposite of 11, which is negative 11. Now, let's substitute 10 instead of x first. 9 times negative 3 times 10 plus negative 11. Now let's simplify what is in parentheses. 9 times negative 30 plus negative 11. Negative 30 plus negative 11, I can do whatever is in parentheses first. 9 groups of negative 41. And then I will multiply 9 by negative 41, and I will get 369 negative. 369. Okay, so let's see if that will work when I simplify my expression first. Using distributive property, I can multiply 9 by negative 3x, and I can multiply and add 9 times negative 11. 9 times negative 3x is negative 27x, plus 9 times negative 11 is negative 99. I cannot do anything else. All I have left is the substitute 10 instead of x. So I will have negative 27 times 10 plus negative 99. Negative 27 times 10 is going to be negative 270, and I'm adding negative 99, and that will be also negative 369, which are equal to our first answer. Okay. So I think you understand the point that when I use distributive property, I'm multiplying the number inside the parenthesis by both numbers inside the outside the parenthesis by both numbers inside the parenthesis. And that we do because we can use our area model when we are using this array to find the areas of each of the addends here and then add them together. Okay. Example 4. Rewrite the expression in standard form using the distributive property. Here I have division. What can I do with division? Same thing I do with subtraction. When I see subtraction, I change it to add the opposite. When I see the division, I would change it right away into multiply by the reciprocal. So when I have that, I will have 6x plus 15 multiplied by the reciprocal of 3, which is 1/3. And then I can do exact same thing. I can make an area model if it works for you better. So I have 6x plus 15, and that is taken 1/3 times. So what I will need to do is I need to multiply 1/3 by 6x to find the area of this. And 1/3 times 6 is going to be 2x, because I can simplify 6 and 3 to make 2. And when I multiply 1/3 by 15, or take 1/3 off 15, is going to be 5. My answer is 2x plus 5. If I don't want to use the area model, I can multiply 1/3 by 6x and 1/3 by 15. It doesn't matter that I have multiplication problem on the other side of the parentheses. It's still multiplication. So 1/3 times 6x over 1, if you want, plus 1/3 times 15 over 1. I can simplify 3 and 6 and make it 2. I can simplify 15 and 3 and make it 5. So I have 2x left, 2x plus 5. Still works. Okay, let's move on to the next. And this is the last page. We are looking at exercise 3. Rewrite the expressions in standard form. So again, here we are practicing subtraction and division. First one is addition and division, then I have subtraction and division. So we right away are going to change division into multiplication of the reciprocal, or multiplicative inverse, right? So I have 2x plus 12 in parentheses, and that is multiplied by 1/2 because the reciprocal of 2 is 1/2. And I'm going to multiply both numbers inside the parenthesis by 1/2. So I'll have 1/2 times 2x and add 1/2 times 12. I can simplify 2 and 2, and I will get x left in the first term, and I can simplify 2 and 12 and get 6 in the second term. I have x plus 6. Same we'll do for numbers 2 and 3. However, we need to make sure to change subtraction into additive inverse. Okay, so this way you know what you're going to multiply your 1/4 by, which is multiplicative inverse of 4. So I will have 20y plus -8 multiplied by 1/4. So I will get 1/4 times both numbers inside the parenthesis. So 20y over 1 plus 1/4 times -8 over 1. I can simplify 20 and 4, and I will get 5y in the first term. And I can simplify 4 and 8 and get 2 in the second term, -2. Okay, and the last one here, again, first change subtraction into additive inverse, and then we are going to change division into multiplicative inverse. So I will have 49z plus negative 7, both in parentheses, multiplied by multiplicative inverse of 7, which is 1/7. So we are multiplying 1/7 by 49z, and we are adding 1/7 multiplied by negative 7. 49 and 7 can get simplified, and I get 7z left. And here I have 7 and 7 that can simplify, and I have negative 1 left, plus negative 1. Okay. Here I have example 5, where I have 3 terms multiplied by the 4 groups taken 4 times. So I will have 4 times x plus 4 times y plus 4 times z. So I have 4x plus 4y plus 4z. There is nothing else I can do about it. I use distributive property and expanded this form. All right, exercise 4, and this is last 2 problems in our lesson for today. So same exact thing. I'm multiplying 3 by 3 terms inside the parenthesis. And I'm doing it because I have 3 groups of all of that. So I will have 3 times x plus 3 times 2y plus 3 times 5z. I will have 3x plus 6y plus 15z. Last one. I have removing 2 groups of that. So make sure you change your subtraction into additive inverse first. And then we are multiplying negative 2 by all 3 terms. Negative 2 times 3x plus negative 2 times 4y plus negative 2 times negative z. I have negative 6x plus negative 8y plus positive, because I'm multiplying negative by a negative here. They have same signs. I have positive 2z. All done. Okay, so I hope it wasn't that complicated, and we can practice more in class if you need to. But this is your homework. It is 1 page here, 3 problems, 1 page. And good luck to you, and I will see you in class. Have a good night.